Hello everyone, welcome to the fifth video in the trees and tree transversals series. And what I want to do in this opportunity is I want to take a look at how we can code these tree transversals, and we're going to go one by one on them. The first thing I'm going to do is just based on the sample on the code that we started writing before, I'm just going to rename my children in my class. The reason for that is because I define them as first child and second child just to have some sort of hierarchy in there. But then we start talking about left and right. So I'm going to change the name just to be consistent with what we have in the slide. So I'm going to say my first child is going to be my left. So I go here, refactor, rename. I'm going to call this left. And this guy will be called right. There you go. Now, just to be consistent, I'm just going to also change the names of the methods. Instead of get first child, I'm going to call it get left. And instead of set first child, I'm going to call them set left. And the same thing for the right. Okay, so now that I have changed all the names of the variables and methods, now we can go and have a second look at the link tree structure that we have in there. We left back in part 2, I think, that we weren't able to create a method add node until we were able to find a node. So that's what I'm going to do is I'm going to create a method public void for now that is going to transfer in a pre-order way the tree. Now, one of the things that we've been saying is that we want to write this in a recursive way. Why? Because if I'm going to transverse the full tree, it is going to be exactly the same thing as transversing a subtree on the left or a subtree on the right. So when we're writing this, the first thing that we need to define is that my attribute for the method should be the node that I'm going to start with. Of course, the first iteration of the pre-order method is going to be the root node, but then the consecutive iterations are going to be the left or right child, depending on the case. So we're going to receive here a node that I'm going to call node, or node to start. We can call it root if you want, but I'm just going to call it node. And I'm also going to write a method that is going to be my visit method. Now, what does that mean? So my visit method is going to be a way to check that I actually have been through that method already or not. So public void visit, and then that visit is going to actually visit the actual node. So I'm going to define it as node. And if for this example, just to get the things, just to get the ball rolling, I'm going to define that my visit method is going to just print the node to the console. So it's going to be a system.out.println of the actual node, nothing else. Now, if I'm in a pre-order sort of iteration, and I should show you the slides again, and a pre-order iteration, I'm only going to visit first the first node, first the node, which is the root, the first one that I'm visiting, and then I go and transverse the left, and then I transverse the right. So that's exactly what we're going to do. So the first one is going to be visit the node that I'm doing. So when I'm saying visit is whatever the method visit has. In this case, it's only printing, but it could be anything. And now I'm going to also do the left-hand side. So it's going to be exactly visit, but in this case, sorry, not visit. It's going to be the pre-order method, pre-order. And instead of passing the node, I'm going to pass the left children, or the left child. So I'm going to say node that get left. And I can do the same thing for the undo. I can do the same thing for the second children, or so the second child. So get right. So what is happening is recursively, I'm going to be calling each one of the nodes one at a time. Now there is another consideration that we need to take into account, which is the fact that at some point I need to have a base case. I need to be able to stop the recursion if I get to the end of the node. So how do I define the end of the tree? Well, I know I am at the end of a tree when I'm in one of the leaves. And I know that the leaves would be a leaf if it doesn't have any children. So at some point, one of these nodes, whether it is the left or the right, is going to be null. So what I'm going to define is if the node that I've been given is null, I'm just going to break the code. I'm going to stop in there and I'm not going to keep visiting, because as soon as I get a null point, then that means that there is nobody else to visit. Okay, let's see if this is true and let's see how this works. And I have a main that already has some links between them. So I'm going to create a new instance. I'm going to take this out. I have my links already created, so all I need to do is I'm going to say linked tree. My tree is equals to a new linked tree. Because I defined two constructors, I can define there the node, the root node, in this case, N1. So once I have the root node, I should be able to transverse in this case. So I should be able to transverse using the pre-order kind of way. So I can say my tree that pre-order. And of course, I need to decide in what node I want to start. But for now, I'm going to say, okay, I just want to start transversing in a pre-order way using the root, which is N1. So if I run that, I should get my list of elements in the pre-order way. So just to make sure that this is actually clear, I decided to draw a little bit of a diagram of what we're getting in there. So I have a root node in this case, which is Amilcar, and I have 4 other nodes identified as node 2, node 3, node 4, and node 5. Now the relationship between them is very interesting, because I define here in line 19 that the left child of node 1 is going to be Leia. That would be this linking here. And I define in line 20 that the right child of node 1 is going to be Luke. And that's exactly what we've done in here. And then I said for the left child of N2, in this case Leia, is going to be Obi-Wan. And I define also that the right child of number 3, which is Luke, is going to be Yoda. Now, when I'm doing the pre-order transversal, what I would expect to find is, remember, pre-order is root left and right. So my first root would be Amilcar, so that would be the first element that I visit. Then I should go left. In this case would be Leia, which is also a root, so that should be the second one. Then I should go left, which is Obi-Wan. That would be the case in here. And now that I have gone all the root and the whole left side, then I should go the right side, and that would be Luke 4th and then Yoda 5th. And that order is exactly the order that we're getting in the console. So my method is actually visiting each one of the elements in the node. And when I say visit, it could be anything. Now, how do we extrapolate this to the other two transversals? So how do we do an in order and a post order? Well, it would be exactly the same idea. It would be exactly the same principle. So this is a point in which you can stop the video for 5 to 10 minutes and try to give it a go. So let's take a look at how do we do that. So I'm going to create a new method that is going to be very similar to the one that I already have. One of the differences is going to be that it's not going to be called pre-order, but in this case is in order. The other thing I know is that the recursion is going to happen with this very same method. So it's not going to be the pre-order method, but in this case, it's going to be the in-order method. The third thing, and without this would be ready, all I need to do is to change the order in which I'm visiting the nodes. So I'm going to call in order for the left-hand side first, then I visit the actual node, and then I go and visit the in order for the right-hand side. So if I do this, I should be able to call now in the main class that method. Let's save everything, and let's call in here the in order method. And let's run this. So as you can see, let's see what we're expecting in this case. Remember, this is in order, so I should have first the left-hand side, then the root, and then all the right-hand side. So if I'm starting in the root, I'm not visiting this yet. I'm going to the left. Now this is a root, so I'm not visiting that yet. I'm going to the left. So the first one to be visited would be 1. Then after I have visited the left-hand side of this subtree, I can go to Leia, which is number 2. And finally, that I have visited all the left-hand side of this tree, I can go with the root, which is Amilcar 3. Now I can go with the right-hand side of this tree, but I'm going to also, same principle applies. I'm going first to the left, there is nobody there. Then the root, this would be Luke, and finally Yoda, which is the right. So the order would be Obi-Wan, Leia, Amilcar, Luke, and Yoda, and that is the order that we're getting in the console. So our method is working correctly. Now, let's take a look at how do we do for the pose order. Pose order would be exactly the same principle, so I'm just going to copy the code again. The method is going to be called post order. That is a method that is going to call that is going to be called recursively. And the visit, the position of the root is going to be at the end. And again, I'm using the same visit method for everybody because it doesn't really make any difference. So I can go to my main class now, and in the main, I can call the post order transversal and run that. Now, what were we expecting in here? Let's take a look at this together. Pose order would be all the left-hand side first, then all the right-hand side, and finally the root. So my root should be the very last element to be visited. So I go here. My root, I'm not visiting that yet. I go to the left. This is a root for a subtree in here. So I'm not visiting that yet. Now I'm going to the left, and Obi-Wan would be the first one that I visit. Now I check the the right-hand side. There is nobody on the right, so I don't have anyone to visit. Now I go to the root. That would be Leia. Now I go up again, but again, this is a root, so I need to visit all the left and all the right before I can actually visit the root. So this would be the next step. However, I need to check the left. There is nobody there. Now I'll go to the right. Yoda would be the next person to be visited. Now that I have visited all the left and all the right, now I can visit this root. And now that I have visited all this left and all this right, now I can finally visit the root, and Amilcar will be the last one. So Obi-Wan, Leia, Luke, Yoda, Luke, Amilcar. So that's exactly what we're getting in the result in the terminal. So that means that our coding is actually working and is actually doing what we were expecting. So now that we managed to transverse the tree, and that we know how to transfer the tree, now we should be able to complete the full implementation of our tree. Now we'll do that in the next video. Thank you for watching, and I'll see you in the next one.